In this video, we're going to explore the most common data formats used for representing and exchanging data: JSON, XML, and YAML. They are all serialization formats, which allow you to store and share data in a simplified form and restore it when needed. They can represent very complex objects in very simple formats. This means that you can easily pass data between systems or programs without needing to carefully parse it each time. First, let's start with a scenario where these data formats come in handy. Imagine you're a researcher diving into the early days of the COVID-19 pandemic in the United States. It's March 13, 2020, and the nation is reeling from the declaration of a national emergency. You want to discover how public opinion shifted in the frantic days that followed. To do so, you gather a representative sample of tweets. But there's a catch: the data is sprawling and unstructured. There are timestamps, hashtags, likes, and other data for each tweet. Without any way to organize it, the analysis becomes incredibly challenging. So how do you store all this data? How do you put it into a file that you can read and that the computer can read? You could use a database table or CSV file, but these solutions only work well for data that fits into that format. These formats struggle with nested and complex relationships. For example, in your dataset, every tweet has a list of hashtags and a list of replies to the tweet. Storing this data in a database or CSV file requires awkward workarounds, and then querying this data can become a nightmare. This is where JSON shines. JSON allows you to store and organize very complex data in a way that makes it easy to analyze, put into a file, and take out of a file. JSON makes it possible to work with complex, nested data in a way that's both flexible and easy to understand. In short, JSON turns your sprawling, unstructured tweet data into a well-organized collection of objects that can be easily manipulated, analyzed, and shared with others. Indeed, JSON is the format that the Twitter API uses to give you tweet information. But JSON and its friends, YAML and XML, are crucial in data science and can be used for so much more than just storing tweets. The three most widely used serialization formats are JSON, XML, and YAML. Each format has its strengths and weaknesses. XML stands for Extensible Markup Language and is the oldest of the three. Its standard was published in 1998. It's more commonly used in older and enterprise systems. JSON, or JavaScript Object Notation, is newer, with a standard published in 2006 and is often favored for web applications. YAML, yet another markup language, is often preferred for configuration files. But before we get into these formats and how they work, I want to quickly discuss the idea of a key-value pair. A key-value pair is a fundamental concept in programming and data storage. It's a way to represent data where each key is associated with a specific value. You can think of it like a dictionary or a real-world filing system where each file or entry has a unique identifier, or the key, and then some information associated with it, which would be the value. So breaking it down, the key is like a label or identifier. It's used to uniquely identify the data that you want to access. In many cases, the key is text, but it can be other data types too, like numbers. The value is the actual data or information associated with the key. This could be anything: a number, a string, a list, another key-value pair, or even more complex data structures. Together, a key and its corresponding value form a pair, often used to represent structured data in programming and databases. For example, you could imagine it like a simple address book. Each person in your address book has a name, which would be the key, and an associated phone number, which would be the value. So, for example, the key might be John Doe, and the value would be 5551234. That's a basic key-value pair. Now that we've discovered what a key-value pair is and how it works, let's explore why this concept is so important, especially in data formats like JSON, YAML, and XML. These formats are designed to store and exchange structured data, and key-value pairs are the building blocks that make it all possible. In fact, when you dive into JSON, YAML, and XML, you'll see that each of these formats relies on the principle of key-value pairs to organize and structure data in a way that's human-readable and machine-friendly. Let's break down how each format uses key-value pairs to represent and manage data. JSON represents data as key-value pairs. The keys, or field names, are always strings enclosed in double quotes, and each key is associated with a value. A value can be a string, a number, an array, an object, or even Boolean values like true or false. Here's an example of a JSON object that could represent a simple tweet. We have user is John Doe, and here the user is the key and John Doe is the value. You have the text is just got my first vaccine shot. The timestamp is March 13th, 2020. It has 150 likes, and it has two hashtags: COVID-19 and vaccine. JSON uses curly braces to define objects and square brackets to define arrays or lists. The keys and values are separated by a colon, and individual key-value pairs are separated by commas. Now let's talk about YAML, JSON's younger sibling. YAML is another human-readable format, but it's designed to be even simpler than JSON, and it focuses on ease of use and readability. Like JSON, YAML represents data in key-value pairs, but it doesn't use curly braces or quotes around keys and strings. Instead, it relies on indentation to define different levels of hierarchy. Lists are represented by hyphens at the beginning of each item. The same tweet above would look like this in YAML. We have user John Doe, text, just got my first vaccine shot, timestamp, March 13th, 2020, 150 likes, and then we still have our hashtags COVID-19 and vaccine. In this YAML example, the keys, or user, text, timestamp, etc., are listed with a colon followed by the value. The hashtags key is followed by a list of values represented with a dash and indented. YAML uses indentation to represent hierarchy. For example, under the hashtag key, each item is indented and listed with a hyphen. YAML is often used for configuration files. It's less verbose than JSON and doesn't require quotes around strings or commas between items. Now, let's turn to XML. XML is the oldest of the three and is used to store and transport data in a structured way. It's very flexible and can represent complex data structures, but is much more verbose than JSON or YAML. XML uses tags to define data elements. Every data element is enclosed in a pair of tags, an opening tag and a closing tag. These tags are surrounded by angle brackets. XML is hierarchical, so elements can contain other elements, forming a tree-like structure. The same tweet in XML would look like this. We can see that we have, for each element, an opening tag and a closing tag. XML elements can contain other elements, attributes, or text. The hierarchy is represented by nesting tags within other tags. You can also define attributes for elements by using key-value pairs within the opening tag, like tweet ID equals 1, 2, 3, 4, 5. Now, what is so special about these three formats? First of all, they're human readable. That is, they're not in bits. They're not in ones and zeros. These formats are text-based, and they're designed to be easy for humans and not just machines to be able to read and write them. That makes them very suitable for configuration files, data exchange, and storing information that's often edited by developers or system administrators. As plain text formats, they can be very easily read and edited with any text editor. This makes them also platform independent, so they don't require any special software, operating system, or applications to look at and work with. Second, they have a hierarchical structure. They can represent complex, nested, and hierarchical data structures. This means they can model very complicated data with many layers, like objects within objects or lists within objects. Third, they are widely supported across programming languages and tools. All three formats are supported by many programming languages and have libraries for parsing and generating data in these formats. There are other data formats as well, like protocol buffers, TOML, and Apache Thrift, but they're less widely used, and so we won't be covering them in these videos. Now that we've covered the basics of JSON, YAML, and XML, let's dive into some practical tools to help you work with these formats. I'll walk you through some tools for working with JSON, but the same tools exist for XML and YAML. First of all, I want to show you how simple these files are. Creating one of these files is straightforward. You simply open a text editor and start typing. Just save it as .yaml, .xml, or .json, and you're good to go. But how do you know if your JSON is correctly formatted? One tool that can make working with these formats easier are validators and formatters. Validators can help you catch common syntax errors like mismatched braces or missing commas before they cause issues in your data. Meanwhile, formatters make the code easy to read and work with by organizing it into a clean and unified structure. Here's a super convenient site that I often work with when I'm working with JSON, the JSON formatter. You can also use these tools online or install them in your IDE. You can also find tools that easily convert between these two formats. Now let's take a look at how we can work with JSON data in Python and R. We'll start by importing the data from a file, manipulating it, and then finally exporting it back into a JSON file. Python makes it really easy to work with JSON using the JSON module. In this code snippet, we're loading JSON from a file and then printing it. Here, we're using the JSON.load function to read a JSON file called data.json. It parses the file into a Python dictionary or list depending on the structure of the JSON file. Once the data is loaded, we can simply print it to see what's inside. In R, we can import JSON files using the JSONLite package. Here's how it works in R. Now, let's manipulate the JSON data in Python. Let's say we have a list of dictionaries and we want to filter out certain values or modify the data. In this example, I'm filtering a list of people based on age. Then I'm adding a new field, status, to each person's record. In R, I use the subset function to filter data. To add a new field, I just assign a value to the new column in the data frame. Finally, let's export our modified data back into the JSON file. In Python, we can do this easily with json.dump. Here, I'm using the json.dump function to write the modified data to a new file called filterdata.json. The indent equals for argument formats the data with proper indentation for readability. In R, to export the manipulated data back to a JSON file, you can use the toJSON function from JSONLite. Here, I'm using the toJSON function, and the pretty equals true argument ensures that the output is nicely formatted. Then we write it to a new file with write. Whether you're using Python or R, working with JSON is very simple once you get the hang of it. Two varieties of JSON you might see in the wild are JSONL, which is short for JSON lines, a format where each line of the file is a valid JSON object, making it ideal for handling very large datasets. Instead of importing the entire file, you can process it one line at a time. JSONP, or JSON with padding, is a technique used to overcome certain browser restrictions by wrapping data in a function call. It's commonly used in older web applications to retrieve data from external domains. Now that you know the basics of working with JSON, XML, and YAML, you can start applying those formats in your own projects. You might start seeing these in the wild. For example, if you've ever worked in R Markdown, YAML defines the title, author, and output formats of a report. Many tools have configs in JSON or YAML. That's it for now. Thanks for watching. If this video helped clarify data formats for you, please give it a thumbs up and share it with anyone who might find it useful. I'll see you in the next video.